So at the end of part 2, we were still doing long division, so let's do another one. So this one is going to be 2x cubed minus 13x squared plus 26x minus 24 divided by x minus 4. So I will go ahead and write that out. And there it is. Remember, my key term is the first term of our divisor, which is that x. So I'm going to figure out x times what is 2x to the third power. And that would be 2x to the second power. So I think this is the first time this section that we've had a leading coefficient other than 1 in our answer. So 2x squared times x is 2x to the third. 2x squared times negative 4 is negative 8x squared. And then we're going to subtract the algebra way by changing the signs and adding them. So the 2x cubes cancel. Negative 13x squared plus 8x squared is negative 5x squared. And then we'll bring down the positive 26x, and we'll do it again. So x times what is negative 5x squared? That would be negative 5x. Negative 5x times x is negative 5x squared. Negative 5x times negative 4 is positive 20x. Change the signs to combine them. So that will be a negative 20x after I change the sign. So the 5x squares will cancel, and remember, those first terms should always cancel. Sometimes that might mean you may need to use a fraction in your answer to get those first terms to cancel, which does happen. So be prepared for that. 26x minus 20x is 6x, and we'll bring down the negative 24. So x times what is 6x, and that should not be squared, Mr. Quarter, so let me delete that. It's just 6x. So x times what is 6x, and that is going to be positive 6. 6 times x is 6x. 6 times negative 4 is negative 24. Change the signs, so we subtract the algebra way, and we get no remainder. So our answer is 2x squared minus 5x plus 6. Second way to do division is called synthetic division. Synthetic division is so named that because it's actually finding the answer to a long division question without actually doing any division. Synthetic division is done by realizing that there are some patterns in long division, and by recognizing those patterns, we can do the division problems much faster. So we're going to follow these 4 steps. Step 1 says to write the coefficients of the dividend so that the degrees of the terms are in descending order. Write the constant r of the divisor x minus r in the box and bring the first coefficient down. That's kind of a lot, pretty wordy there. So basically, we're going to write the coefficients of the dividend. So the dividend is normally what we would write inside the box. So the coefficients of the dividend are going to be the 2, negative 13, 26, and negative 24. And then it also says to write the constant r of the divisor x minus r in the box. What that means is, and you're going to have to follow along with this, with the pattern, is that inside a little box on the outside, we're going to write the constant of the divisor. So the constant of the divisor is negative 4. But what we're going to do here is we're going to write a positive 4 in here. We're going to do a sign change. So instead of a negative 4 that's in the divisor, we're going to write positive 4. And the reason we can do that sign change is that, remember that every time that we did long division, on every step, we had to change the signs before we added. Well, in synthetic division, if we do that one time, we don't have to change the signs for the rest of the entire problem. So change the sign right off the start. In synthetic division, we will not have to change the signs for the rest of the problem. And then also in the same first step, it says bring the first coefficient down. So we're going to have 3 rows of numbers here. We're going to bring the first coefficient down to the 3rd row, just like that. And then we are going to multiply the first coefficient by r, so the r meaning the part that's in the box, and then write the product under the second coefficient. So we are going to multiply 4 times this 2 that we just moved to the bottom row. We're going to multiply that, and then we're going to write the answer in the second row of this second column. So 4 times 2 is 8. We're going to write that answer underneath the 13. The third step says add the product in the second coefficient. So we're going to add these two numbers together. We're going to add those two numbers together. We're going to take negative 13 plus 8, and that gives us negative 5. We're going to place that in the bottom row of the second column. The final step says repeat steps 2 and 3 until you reach a sum in the last column. So we're going to continue to do that same pattern. We're going to continue to multiply the number inside the box times whatever we have on the bottom row, and then place that answer here in the next column. So 4 times negative 5 is negative 20. We'll place that answer right here, and then we're going to add these two numbers together and place that in the next column. So 26 plus negative 20 is positive 6. And then we'll do it one more time. We'll take the 4 that's in the box times 6, which is 24. And then when we all add negative 24 to the positive 24 we just wrote, and that will give us 0. So we get this bunch of numbers in rows and columns. So what in the world does that actually mean? Well, here's the problem that we did, the last problem we did on long division. As you can see, it is exactly the same problem as we just did in synthetic division. So look at the answer of our long division problem, and then look at the bottom row of the one we just did with synthetic division. Do you see some similarities? There are definite similarities. So if I'm reading this from right to left, notice that the 0 in the far right column was the same as our remainder of 0. So this last number represents the remainder. The 6 is the same as the 6 that we have in our next column. This number represents the constant. The next term was negative 5x, again reading from right to left. The negative 5 in our next column represents the x column, and the 2x squared represents the x squared column. So what we do is we interpret the bottom row. Starting from the right, the last number is always going to be the remainder. The number next to that is going to be the constant, and the number to the left of that is the x term, and the number left of that is the x squared term. So looking at that bottom row, we can see that the answer generates the same solution as long division of 2x squared minus 5x plus 6 with no remainder. So these are the same answers. There is a limitation to this, is that synthetic division only works when the lead coefficient is 1 and the highest exponent is 1. And now I'm talking about the divisor on that. So it only works when the lead coefficient is 1 and the highest exponent is 1. If the lead coefficient is anything but 1, and that includes even a negative 1, or if it has any exponents in the divisor, synthetic division does not work, and you have to do long division. So let's try a couple more examples. So 5a is 2x third plus 3x squared minus 4x plus 15 divided by x plus 3. So before we try to do synthetic division, let's make sure that we can do synthetic division. Does the divisor have a lead coefficient of 1 and an exponent of 1? And that is true, because there is a hidden 1 as the lead coefficient in front of this x, and there is a hidden exponent of 1 behind it. So we can do synthetic division. So we write out our column here, or our row here, of 2, 3, negative 4, and 15. And then inside the box, we're going to put not 3, not this number, but we do the sign switch. We're going to put negative 3. Remember, we have to do a sign switch. Do it one time. We don't have to do it anymore after that. So the first step was to bring the bottom number, or the first number, down to the bottom row, and then do a series of multiplication and additions. We start out by multiplying negative 3 times the 2 we just brought to the bottom row. That's negative 6. And then we add those to get negative 3. Now take negative 3 times negative 3, that's positive 9. We add those to get 5. Negative 3 times 5 is negative 15. We add 15 to negative 15, and we get 0 there in my last column. That's usually a good sign because that represents the remainder, which means that this answer will have no remainder. The 5 is the constant. It's a positive 5. The negative 3 represents the x term, so negative 3x. And the 2 represents the x squared term, 2x squared. So this is the exact same answer you would get if you did a long division, and it is much faster, and I encourage you to use it whenever possible. We're going to do one more. 4a to the 4th plus 2a squared minus 4a plus 12 divided by a plus 2. So can we do can we do synthetic division? Yes, we can, because the lead coefficient is 1, has an exponent of 1, so it will work. So when I write my numbers down, I want you to remember something. I want you to remember that we have 4a to the 4th, but notice that there's not an a to the 3rd term. So just like with long division, when I have to put in some zeros for any missing terms because maybe it skips the a to the 3rd or an a to the 2nd term, we still have to do that with synthetic division. So I'm going to place a 0 in here to represent 0a to the 3rd because there is no a to the 3rd term in our dividend. And then I'll have 2a to the 2nd, negative 4 for the a, and then the constant is 12. And then what's in the box? What's in the box? It is going to be a negative 2 because we do have a sign switch on this 2 that's right there. And then we do our synthetic division. So we bring the first number down, and that's going to be 4. Take that negative 2 times 4 is negative 8, and then add. 0 plus negative 8 is negative 8. Negative 2 times negative 8 is 16, and then we add. 2 times 16 is 18. Negative 2 times 18 is negative 36. We add those to get negative 40. And then finally, negative 2 times negative 40 is positive 80. We add those to get 92. So we do have a remainder this time. Remember how we write remainders. We write them as 92, the remainder, over the divisor. The divisor was a plus 2. So a plus 2. So that is a 9. Look kind of like an a. The number to the next to that, this negative 40, that represents the constant. The number next to that represents our x term, so positive 18x. The number next to that represents the x squared term, so that'll be negative 8x squared. And I think it was supposed to be a's, isn't it? Yeah, it's supposed to be a's, Mr. Corder. What are you thinking? So a and a squared. And then the number next to that will be 4a to the 3rd power. And there's your answer.